our presentation today, from literature to lab, effective topic selection and research execution in pharmaceutical formulation. Now we are going to develop our formulation. Now for that, how to go ahead? These are the contents. Let us see one by one. Now the first one. What is this is called as? Biopharmaceutical classification system. Why it is used? Where you are going to use this biopharmaceutical PCS classification? To classify the drugs. We are going to classify the drug. We are going to classify the human beings also. Agree or not? Two students are there. Depending upon your result, I am going to classify. I will tell the students with greater than 95%, students from 70 to 95, students from 50 to 75 and less than that. So here, I have classified the students based upon the marks into 4 types. Here also, based on solubility and permeability, we are going to classify the drugs into how many types? What are the 4 types? Agree? Now, if you look into this class 1, what is class 1? Highly soluble and highly permeable. No issue with class 1. No issue with class 1. In simple, I will tell you, the students who come to college regularly, maintain their attendance, listen to the classes, they don't have any issue with the passing of the subjects. Agree or not? In the similar, the class 1 are those drugs whose solubility is very high, whose permeability is also very high. So your teacher doesn't need to put effort on them. Yes or no? Agree? అట్లాంటి పిల్లలకి చదువు చెప్పకపోయినా వాళ్ళు చదువుకుంటారు. అవునా కదా? So those molecules are class 1. Now issue is where? Issue is with class 2, class 3 and class 4. Now how do you remember this class 2, class 3, class 4? Exactly opposite of class 1 is class 4. Where solubility is very less, permeability is also very less. This is solubility and this is permeability is also very less. So exactly the opposite of class 1 is class 4. No solubility, no permeability. Now what is class 2? Class 2 is where solubility is very less but permeability is very high. Okay? So that means if I am going to address the solubility, I can develop a formulation there. Okay? Permeability. No problem with the permeability. If the drug comes across the GIT, it will permeate. Okay? So we need to address the solubility issue there. Now, exactly the opposite of class 2 is class 3. What is class 3? High solubility but low permeability. Banda in the sense drug molecule. Now you are a drug molecule for me. Your solubility is very high but you are not permeable. Agree? So now the issue is we need to address the issues of class 2, class 3 and class 4. Now you decide where you belong to. Now you have selected your drug molecule. From that drug molecule you will come to know whether you are 1, 2, 3 or 4. Let us look into that. Now how do I classify all these drugs into these 4 classes? This is based upon what is called as the solubility and the permeability itself. Okay? Now, when do I say that the drug belongs to class 1? I say the drug belongs to class 1. Here, if you see this particular class, this is the volume in ml. If my highest dose of the drug dissolves in 250 ml of dissolution media, what I am saying, if my highest dose of drug dissolves in 250 ml of dissolution media, I am calling it as highly soluble. Either it is a class 1 or class 3. Am I clear to you? Now, what is the highest dose of paracetamol? Highest dose? 500 mg. Even 650 mg. Doro contains how much of cholesterol? 650 mg. Agree? If the 650 mg of paracetamol dissolves in 250 ml of dissolution media, it may be distilled water, it may be hydrochloric acid with 0.1 pH, pH 1.2 or phosphate buffer, pH 7.4. Any of these three. If 650 mg dissolves in 250 ml of the media, then you are called as freely soluble. Freely soluble. And at the same time, if your permeability, you can see permeability, if the permeability is 10 to the power of minus, here 1 in between 1 to 10, here you can see 10 to the power of 5, then we call you are freely permeable. You are freely permeable. So you can see here permeability 1 into 10 to the power of minus 6. If it is 1 into here, okay, 10 to the power of 5 here, then we call it as highly permeable. Agree? Now this is how you should know whether you are soluble or permeable. Okay? Now, can you see this figure? Agree? Now, focus on this figure. Now what is the issue I told? The issue is you belong to either class 2, class 3, class 4. That is the reason there is a difficulty in your absorption, distribution, elimination or metabolism, whatever it is. End of the day, you as a pharmacist, research scientist, you should come with a formulation development. Agree? And in the market, most of the drugs are available as tablets. Why it is tablet? It is easy to take, easy, conventional. Anybody can take 2 times or 3 times you can take a tablet. Rather than if I ask you to take an injection. Painful, patient complaints is not there, painful, a skilled person is required. Agree? So now, let us assume that our formulation approach is oral route. Agree? Our formulation approach is oral route. Now how to come up with a formulation development? There is an issue. There is an issue. Agree? Now, what are the important physicochemical properties of the drug I told? Solubility and permeability. Agree? In case of pharmacokinetic properties, I told we should look into the bioavailability, half-life of the drug, protein binding. Only 3-4 properties I am giving for here. Agree? Of course, there are many other properties, but on a PhD level, we will look into that. Okay? Now, here, you as a drug, what here? Am I clear to you? You as a drug, either you belong to here, class 2, class 3 or class 4. Am I clear to you? Now, when you are here, how you need to select the formulation approach? We don't know. I don't know anything, you don't know anything. What do we know? We know only about the drug properties. Am I clear to you? Now, so here, when you think that you are going to start here, where the drug is either 2, 3 or 4. As per your PCS classification, you belong to class 2, class 3 or class 4. Am I clear to you? First thing what you have to look. Can a salt be made? Now your madam is there, chemistry, your PhD, your Vijaya madam is there, she is pharmaceutical chemistry. If you give her the structure of the drug, she will tell you whether a salt form of the drug can be prepared or not. Am I clear to you? For example, diclofenac. Can I prepare diclofenac sodium? Can I prepare diclofenac potassium? Why salt form? Salt form of the drug increases the solubility. The simple approach. What is the first simple approach? Whether the drug API can be converted to a salt or not. Okay? So go to your chemistry madam, ask, madam, this is my structure. Help me. Can I prepare a simple salt or not? Simple approach, in the lab we can work it out. She will tell you simple procedures. And if the salt form of the drug is possible, you where the solid form of the drug, problem is resolved. Agree? The solubility has been increased. Prepare a salt form. Without salt form also the drug is there. Compare the solubility of the salt form and the normal API. You will come to know how many folds increase in solubility is achieved. Am I clear? Very simple. Drug is not soluble. Diclofenac is there. Diclofenac sodium, diclofenac potassium, you prepare. Look for the solubility. Solubility increased or not? End of the day, what we need to do? We should increase the solubility of the drug. We should increase permeability of the drug. Now, okay, if I can prepare a salt form, yes. What is the statement? Yes. Look whether your salt form is soluble in water or not. So, water solubility you are going to check. Now, if yes, the drug is water soluble, immediately you can go with the salt form of the drug, okay, where you can add the group or you can adjust the pH. If you adjust the pH also, the solubility of the drug increases. So this is the first simple approach. So that means I am a drug here belonging to class 2. I am at this particular point. Now I am here. I am insoluble. I will see whether I can become a salt or not. Yes. Then I will come forward. Yes. Soluble. I can prepare a salt. Go ahead with that particular simple step. If no, you can see. If no, what is the second important property of the drug you have to take? Log P. What is that? Log P. Now, if you open for your drug, every drug will have its own log P. Log P can be even minus beta. Log P can up to go 6, 7, 8 months. Okay? So, if the log P is below 3, if the log P is below 3, you are hydrophilic in nature. You should know that. If the log P is less than 3, hydrophilic. If the log P is greater than 3, you are lipophilic. You are lipophilic. Am I clear to you? Look for log P. Minus, log P is minus. That means you are freely soluble in water. If the log P is minus 0.2, you are freely soluble in water. Am I clear to you? So look for the log P. So here, so you cannot become a salt. I cannot become a salt. The next important property what I am looking is for log P. So if the log P is less than 3, I wrote here low. If the log P is less than 3, what is the approach you have to use? Co-solvents. Again I repeat. What is the log P? Less than 3. So the simple approach for that particular drug molecule is prepare co-solvent. Prepare a formulation approach by co-solvency. Co-solvent. What is co-solvent? Say for example, a water is there. For water, a co-solvent is glycerin, propylene glycol, ethanol, methanol. Am I clear to you? So that means if the drug is not soluble in directly water, but a friend of your water is ethanol, methanol. What you do? Take your drug, dissolve ethanol in 5 ml and combine the remaining ml with water. Solubility is increased. So this is an approach called as co-solvency. Agree? So when you go for co-solvency as an approach, when the log P is less than 3. Am I clear to you? Now this is our second formulation approach. What is our first approach? Salt formulation or pH adjustment. No, I cannot form a salt. You cannot form a salt. Look for log P. If the log P is less than 3, simple approach is co-solvents. Am I clear to you? Check. Problem resolved. Immediately go to the co-solvent as an approach. Look in the lab whether you have the co-solvents or not. Select that, do the study. Okay? but my log P is okay, now log P is not 3, it is high. What I have written here? It is high. Focus on the slide. Log P is greater than 3, high. So what is the next important point you have to look for? Melting point. What you need to look for? Melting point. Agree? Log P is now greater than 3. Okay? So the next important property which you have to look is melting point. In fact, this particular tree, this is called as decision tree. What is this tree called as? Decision tree. Agree? I am in front of your university. I don't know how to come to your university. What do? I use Google Map. I just follow the Google Map. The same thing here. I don't know what formulation approach I have to use, you have to use. So therefore simply follow the decision tree. The tree will give you the solution. Okay? Now, so the next important property is if the log P, you can write a statement. If the log P is greater than 3, if the log P is greater than 3, look for melting point. Look for melting point. Okay? Now, here I have written melting point low, melting point high. Now, low. Again, when I say melting point is low, low in the sense up to 60 degrees. If the melting point is up to 60 or less than 60, if the melting point is